Testing. Hi. Testing.
Audible.
Hi.
You are audible.
Yeah. Okay. Is everyone in the room?
Yeah, I can hear you, Miss Amida.
Okay. Aisha, I think we can start now.
Yeah,
Shall we?
yeah, we should.
All right.
Okay, so hello everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 9B. My name is Alesha Mulla, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026 in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held in London on 24th of February, and the virtual event is being conducted on Zoom from 25th to 27th February. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we will have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the end of the session. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for this session. Associate Professor Dr. Asmedar Abubakar is an associate professor and prominent researcher at University Tenaga Nasional, Uniten, Malaysia. With nearly 20 years of academic experience, she serves as a senior lecturer in the College of Computing and Informatics. Her core research areas include information security, cybersecurity privacy, access control, trust, and machine learning, with a strong focus on developing secure and intelligent computer systems. Dr. Abubakar, I please request you to say a few words.
Hi, everyone. Welcome to ICICT 2026. Hope everyone enjoyed the session, even though it's going to be on a hybrid online session. Back to you, Alicia.
All right, thank you, ma'am. We can now start with the presentations. Our first presentation for today is by Ayan Dutta, who will be presenting a unified AI framework for text-based defect detection and root cause prediction using enterprise bug logs. Ayan, you may now start your presentation.
Thank you. Am I audible?
Yes, you are.
Yeah, we can see you.
Good evening, all respected chairs, panel members, and dignitaries. I'll just share my screen. Just let me know if my screen is visible or not.
Okay.
Is it visible?
Started sharing. Okay, now, yeah, we can see that.
Now you can see?
Yeah, but you have to put in the presentation mode. Now it's
Yes,
not in the presentation mode.
I understand. Let me do it and then share. One second. One second. Yes. Yes. Is it fine now?
No. Okay, now we can see.
Now
Clear.
you can see. Okay,
Yep.
great. So
I hope the rest also can see.
yes,
Okay.
yes.
All right. You're good to
So,
go, Mr.
good
Ayan.
evening. Good evening. All respected chairs, panel members, and dignitaries. Today I will be presenting a unified AI framework designed to tackle the growing complexity of software maintenance in the enterprises. So this paper, as you can see from the title, it is a unified AI framework for text-based defect detection and root cause prediction. It is authored by me. I am being the presenter, and also co-authored by Mr. Golden Raymond and Mr. Pranay Khandagle. My co-author will be joining very shortly. Meanwhile, I'll take it forward with the presentation. Uh, yes, so as we can see, as we run down the table of contents, we will first let you know about the background and the need for study to bring out such a paper. Then we will say about the solution we are proposing, that is the Unimix hybrid model, and how it is different from the traditional bird-based and S-bird-based models. We will show you the model architecture, the methodology behind the model preparation, and then we will compare the performance matrix, and then we will tell about the conclusion and the future prospects. So let me walk you down through the background first. So as we see where the problem lies, we see that today nowadays traditional software testing is facing a huge amount of challenges in terms of test case generation, test case execution, and all those things, because with the advent of AI, the software systems are becoming complex, and also it is hard to manage single-handedly. So AI, but again, the AI techniques bring with it the opportunities to enhance the efficiency and intelligence in the software quality assurance domain. So one of them we have put into this research paper, which is the by using NLP, that is natural language processing, we have tried to find out the root cause of the enterprise level issues. So if we see why the need for such a study have arisen, we see that the scale of software failure is really staggering. With malfunctioning software can cost the global economy over $2 trillion annually. So in a large-scale enterprise environment, we often see that 10,000 issues are reported per year, even more if you see. And then, however, if you compare it with how much can be handled by human, it's very less. The human can only triage per week maybe 50 to 100 or max 500 issues. So which creates a really huge amount of bottleneck. So currently, and also if we see that the manual workforce is about only 30 to 40% is there. I mean, and also much of the time is lost for debugging. That is, quarter of all issues either becomes duplicate and also which wastes time of the critical resources. I move to the next slide where the solution is proposed. So, one second. Yes. So here, if we see that to address such kind of challenges as we mentioned above, we can propose the Unimix hybrid model. So if you see in the right hand side, I have briefly mentioned the basic hierarchy for the model which we follow. It's a basic issue is broken down into conceptually, the issue is broken down into its lexical features and the semantic embeddings. The lexical, for the identifying the lexical features, the underlying concept is TF-IDF. As we all know, it is term frequency and inverse document frequency for root cause analysis. And for semantic embedding, we have this truncated SVD. So this is the underlying concept for coming out with the model. So if we see, if we use the model into the current domain, we can see that by fusing these two concepts together, the framework can work better, handle noisy or very short bug logs that traditional models might struggle to categorize. So I move to the next slide now. So if you see here, the model which we have come up with is like when you see the enterprise bugs or enterprise defects, first we do the pre-processing. If you see the next node in the slide, I'll move my cursor over here. we do the data ingestion, we do the pre-processing, all those pre-processing things. Then we put the feedback loop for model improvement. That is another thing. Now we, as I said earlier, we break it down to SVD for semantic embedding, which is contextual, and TF-IDF, which is lexical, which is straightforward, if you say. It's superficial. So then the merge the amalgamation of these two things becomes our Unimix fusion, which is the core structure of our model. We can concatenate and scale through it. Then it brings the UMAP brings out the UMAP for dimensionality reduction and HPD scale and so on. Okay, for this. So duplicate detection and other things we can do by using this model. I move to the next slide to further explain the same thing, basically. So if you see here, we ideally for the pre-processing method, we did normalization. First, the cleaning the text by removing maybe non-alphabetic characters and standardizing terms like error, main terms like error and page. These things can be standardized in the issue because the issue is text-based. Then we perform the core architecture on it, which is UMAP and the UMAP for dimensionality reduction and HPD scan for clustering, as you can see in the particular slide. Then the output gives the end result, which is an automated root cause analysis that groups the defects into the primary themes, such as it can be an UI navigation, it can be a transactional error, it can be related to authentication and authorization. I move forward with this respect to this slide. If we see why we have used the Unimix hybrid model, we can analyze from this performance metrics. That is, when we look at the data which we have used as our data set, the Unimix hybrid model clearly outperforms the standalone methods and the traditional methods like if you see k-means clustering or SBERT only. It achieves, if you see, it has achieved a Silhouette score of 0.41, which indicates much better separation between the defect groups compared to the 0.29 score of a standard TF-IDF approach. And again, if you see, the model also showed a high cluster coherence, which is 0.78, which is the themes it identifies are highly interpretable for human developers, and so can be worked upon further. So crucially, its ability to handle short text was rated. If we have just categorized the short text, it can be rated as excellent compared to the traditional methods, which were not as at par. So the model has captured the most frequent words, which is like page, error, and there are also catchy words like reimbursement, accounts, whose frequency are much less, but contextually they are as much important. So I move to the next slide. We come to the conclusion part here. So when we look at the data, the Unimix hybrid model which we used clearly outperforms the standalone methods, as I told earlier. So this framework provides a scalable, automated way to triage the faults, perform the root cause analysis without needing a perfectly labeled data set. Unlabeled data set can be used. So if you sum up, it bridges the gap between the technical jargons which are there in the data set and the actual intent of the issue of the reporter who is reporting the issue. And this is how it identifies the root cause. Looking ahead, what we can do, we can plan. If you, I mean, in the slide, it is also mentioned future prospects. We can plan to integrate it into the LLMs, large language models, the GPT and other things which we often see, to further enrich the contextual insights and connect the system directly to the trackers. We have Zoho bug tracker in our usage, so we can also integrate it with them for real-time automation and going other things going forward. So and also to incorporate the code snippets and the stack traces involved in this process. So here I conclude my presentation. I would like to have, I mean, if there any question and answers, I would like to.
Okay. Thank you, Mr. Ayan. Is there any question from the floor? Okay, Mr. Ayan. I'll ask you because this
Yes.
you are saying that you are saying that you are using this hybrid model instead of using full transformer
Can I
model
stop my
directly, right?
sharing? Can I stop my sharing?
Yeah. You can start
Thank
sharing.
you so much.
Okay.
Okay.
Okay. My question is here. Why? What is the justification for combining the TF and IDF with the semantic embedding? Yeah, in your research.
Yes, like in my research, if you see, we have the data set is not like the real world sort of whole language based models. Where, I mean, the data set is almost a subset of the real world, what the words and the sentences and all the things we use in a language. It's the whole set where the big heavy power, heavy duty models like SBERT and BERTs are used. Here, if you see, the enterprise issue logs are mostly related to small set of data set. Like it is a subset of the larger amount of data set. It might be relevant to only a particular domain or a particular aspect involved, which is in terms of issue, let's say login failure, access control issues, and other things, say, page not working, web page not opening, something like that of the sort. So a lightweight model we have tried to use, and that is the reason behind we have used the hybrid model rather than using the heavy duty model of this Roberta and SBERT and all things.
Okay. So you are saying that this hybrid model would be computational costs better as compared to the
Yes,
transformer only model, is it?
because the data set is lightweight, and using a heavyweight model on a lightweight data becomes very unsustainable. It's not cost effective, and that's why to handle a lightweight data set, a lightweight model has to be prepared, which I feel is convenient.
Okay. So at the end, do you think that your work can be extended using BERT models? But you are saying about the BERT just now, right?
Definitely.
BRT,
Correct.
huh?
Definitely, it can be used, but since the data set involved here is very limited and not only limited to the enterprise level words we often use, so that is the main thing we have used this hybrid model instead of BERT. But BERT can be often obviously used. Yes.
Okay. Thank you. Good research. Thank you, Mr. Ayan.
Thank
Okay.
you.
All right. Okay.
Thank you so much for your
All
time.
right. Aisha, are we on track?
Yep.
Okay.
All right, so the next paper is by Ezra Talab, who will be presenting Authentication Approaches in the Internet of Drones, a critical review of challenges and emerging solutions. Ezra, you may now present.
السلام عليكم.
Assalamu warahmatullah.
I share my project. Is my presentation is on your screen?
Yeah. We can
It's
see
my
the,
pleasure. Thank
yeah.
you. It's my pleasure to present my work, authentication approach in Internet of Drone, critical review challenge and energy solution. Or when? Or, outline. What?
You are breaking. Okay. Kind of breaking. Hardly hear your voice. Isra?
What? نعم. Yes. Can
Now
you hear me?
yeah, it's kind of breaking just now. Okay. Can you continue?
Yes, I see you. Do you see my screen?
Yes, I can see your screen. It's just that your voice is breaking just now. All right.
Now,
Now I can hear you. Okay, please continue. Thank you.
oh, okay. Outline, introduction, security challenge, and attack in IoD authentication, attack and solution, related work discussion and research gap, conclusion and reference. The introduction, the field of UAV or drone communication was rapidly development in recent years. Drone or human aerial vehicle are characterized by high degree and adaptability to complex application, easy to movement, wide coverage, and ability to access remote or dangerous area that difficult to human to reach. General, the IoD abroad network performance in terms of efficiency, response time, and reliability. In spite of this benefit, the UAV environment faces a number of challenges. One of the major one ensure secure and reliable communication. Especially the IoD ecosystem is vulnerable in myriad of security and privacy threats. This is mainly attributed to continuously movement of drone, technological diversity, response time, constraints of remote data exchange capability. Therefore, enhanced security techniques are required for effective, mutual, lightweight, continuously, and multi-factor authentication. The goal of review is various feature to attack passing the environment, including these various solution to mitigating them, and ensuring the confidently preventing identity thief, replay attack, as well as challenging, enhancing overall security and releases in the network. For instance, the sensitive exchange in open public internet which is exposed to a material field threats such as prevention, identity thief, replay attacks, phishing key hijacking, decision key disclosure, forgery, stolen verify, man in the middle attack, drone capture, eavesdropping, side channel attack of guessing, and privilege insider. Security challenge and attack and an IoD authentication. The IoD ecosystem characterized with the machine that is critical and secure and authorized in communication. Effective security measure in IoD environment can be help protect transisted data and prevent unauthorized access, such as crucial to verify the identities of the network, including drone, ground control station, and the cloud computing servers. However, several factors present some challenge in IoD authentication. For instance, the dynamic nature of the network and the sensitive of data exchange using wireless and public communication channel. This message forward render the protect the IoD environment cookie tracking. Therefore, the development the strong authentication we need to techniques that exterminated important for protect the system against security attack. And below some main attack and the solution. Attack and solution. Spoofing attack solution by implementation. The strong encryption based on authentication protocol can ensure successfully identity verification, which includes secure key change protocol based on ACC or implementation certificate or based on biometric authentication, as well as secure token change. And then on the middle attack can use solution by robust multilateral authentication protocol must be implementation. These joint verification techniques ensure in both parties the verify identity and each priori exchange any data. Replay attack solution by ensuring all the message exchanged during the authentication process are fresh and adding by a timestamp random number challenges and knownness in this message. Denial of service solution by using PUF, physically unclonable function can be generate and queue fingerprinter through the system diagnostic between ligament or unsure entities required for the service. Lightweight authentication machines or distribution blockchain techniques. A cloning attack solution by ensuring all identities of the device verified using biometric verification and queue techniques or trusted devices. Drone impersonation solution by natural authentication protocol must be implementation between IoD system techniques such as PUF or ECC can be combined and deploy the authentication between drone and control station. Session hijacking solution by setting strong expiration duration at all session, encrypted all authentication. HTTPS can be implementation for the secure session management with the renew token or and cookies. Modification attack implementation by robust encryption and sync force messages which enhance to integrity of transmitted content. Physically drone capture solution by using PUF can be deployed in both drone and ground control station. Cryptographic techniques can be implementation to convert identities and information stored in a drone into the message against. Moreover, a tamper detection machine can be deployed to at the drone or the ground station. Now, session key attack solution by strong mutual authentication, ensuring complete confidentiality system and key in both forward and backward direction. Moreover, key parameter must be updating after each authentication process and the new session key complete. Stolen smart device attack solution by implementation multi-factor authentication using password or smart card and fingerprinter. Ground control station impersonation solution by implementation natural authentication achievement techniques such as PUF. User impersonation solution by using multi-factor authentication protocol or authentication scheme based on biometric. We have 10, looking at authentication scheme, we have 10 reference in Q1 in around in 2024, 2025. The method use symmetric cryptography, PUF, encryption, XOR, hash function, biometric, and fuzzy extraction. And the performance of most of them is balanced between security and efficiency. Operational offer that the drone limited resource. Limitation of most of them, they are tested in their scheme in virtual authentication and limited in scalability and integrity. And some of them doesn't guess some attack like side channel forgery, visit dropping, denial of service, backward and forward security. This scheme. Now, conclusion: the research gap. Most of the studies focused on authentication between the drone and the ground station. Moreover, authentication and themselves on the cloud has not been completely addressed. When comparing various feature to realize the lightweight authentication for resource constraints IoT devices. This campaign must often result the extensive energy, communication, and storage overhead. Among the conventionally security solution, response to advanced security threats such as distribution, denial of service, man-in-the-middle attack, replay attack are still limited, and the scalability and the capability, computability among them IoT system. Challenge related weakness in security threats such as jumping, GPS spoofing, authentication, high computation, and storage and key management issues. All these challenge highlight to need for further research efforts to reduce them. Conclusion: this study focused on challenge and cyber attack and how solutions are used in a drone environment. Authentication in BIOD environment is a basic in ensuring secure communication among the drone and control station and the cloud infrastructure. However, owning inherent vulnerabilities in IoT ecosystem has exchange and sensitive data over public channel security threat, targeting the data confidentiality and operational integrity are on the rise. Therefore, we are in need a lightweight protocol that do not adversely affect to actual performance in the drone. In addition, various advanced threats such as replay attack, man-in-the-middle attack, spoofing must be mitigated. It is also being realized in this dynamic nature of the IoT ecosystem required an environment and a robust solution for identity management and key distribution. Consequently, there is the need for future work focusing on authentication protocol that can stick a good balance between security and efficiency and reference. Thank you for listening.
Okay, thank you, Isra. We open to the floor for the question.
Yes. Can you see me?
Yeah. Open to the floor for any question with regards to authentication approach in the Internet of Drones. Do we have any question from the floor? Okay, Isra. You are saying just now it requires strong authentication mechanism in this IoT system, right? So what will be the practical authentication in IoT environment, taking into consideration IoT constraint, yeah, the drones constraint is the constraint that drones facing. So what are you suggesting?
My purpose deploy strong authentication techniques to protect IoT environment, make a balance between security and efficiency. That consider the limitation resource of a drone. Can I make a hash function timestamp XOR, and this make them in operation to make this balance.
Just now you are saying that it should be lightweight authentication, right? So based on the current work, they have not produced any lightweight authentication for drone? For Internet of Drones? Because just now you said that drones to drone, they have to communicate each other, they have to authenticate each other prior communication, right? Prior passing the data. So what are the current works? How does one drone know another drone in Internet of Drones communication based on your study?
Can you repeat the question?
You are saying that just now, okay, there are very limited works on how drone is being drones authenticate another drones, right? Because we are talking about internet of drones. So what are the current work how can drone authenticate each other on the network as based on your study now?
I don't understand what
There's no authentication between drone to drone authenticate to the ground.
Okay. Hello. Hello.
Is it all the drone authenticate to the ground?
I don't know, make this question in future work.
No, in your slide just now you say there's no authentication between drones to drones. Am I right?
Yes.
Okay. So now every drones been authenticated by ground only.
No, by a ground a gateway server in between the drones and the user operator.
So okay, now moving forward from your work, what are you actually what's the issue what will be the core issue that you want to prove, that you want to work on? Is it drones authentication or what?
Drone authentication.
You mean between drones to drone on air, when they fly, they have to be authenticate each other.
Authentication between the drone and the server and user in wireless Wi-Fi.
But they already have the internet connectivity between drone and the server, right? Because when they launch, they tag each of the drone belong to that network. Am I right or not? This is just like VANET, vehicle on the network, but now it's replacing the vehicle, putting it as a drone. Do you think that looking into VANET solution or idea can place to drone? Have you looked into that angle? I mean, it's just a suggestion. Perhaps you can look into that. Okay, all right. I think that's all. With regards to that's all. That's the question that I want to highlight to Ashra. Thank you, Ashra.
Thank you.
Okay, Alicia, back to you.
All right. Yeah. So our next presentation is by Rami Alassi, who will be presenting digitized Archimedes spiral test for tremor screening in Parkinson's disease, designed considerations for a proof of concept mobile application. Rami, you may now begin.
All right. Am I audible?
Yes, you are.
Yeah. Yeah.
Okay, I'm going to screen share now. Okay, is it good? Can you see?
Yes, you're good to go, Rami. Thank you.
All right. Okay. Hello everyone. My name is Rami Al-Assi. I'm going to be presenting to you our research titled Digitized Archimedes Spiral Test for Tremor Screening. It is done by me myself, Hamad Ala, and it is under the supervision of Dr. H. Selim, Solimath, and Solimathu. We are representing University of Wollongong in Dubai. Now, to start off, for the introduction, Parkinson's disease affects over 10 million people worldwide, and tremor is one of the most common early symptoms. One of the most common clinical methods to assess tremor is the spiral Archimedes. So this test basically is you have to draw over the spiral, and what's special about it is that there is equal space between the lines, so you can easily assess for any tremor or shaking of the hand. The problem with this is it's subjective and it depends on visual interpretation by the clinician. So it basically depends on the experience. There is no standardized quantitative assessment for this, and the test must be performed in a clinical setting, which is what motivated us for this digital alternative. Now, for the background, Parkinson's disease is a progressive neurological disorder, which means it worsens over time. It affects movement and other motor functions of the body. There are two types of tremor. There is the rest tremor and the action. Rest tremor occurs when there is involuntary action and the person is at rest, or when the muscles are relaxed. Action tremor occurs when there is voluntary action. Now, why is it important to early detect Parkinson's? It will increase the possibility of delaying the disease. It will also help with neuroprotection, which will basically slow down the dying of the brain cells. It can also help with being eligible for possible clinical trials, and it can decrease symptoms. Now, for the existing assessment methods for Parkinson's, there is the drawing Archimedes spiral and handwriting tests and line drawing tests. However, these methods have several limitations. They rely on subjective evaluation and they lack quantitative scoring. And they also typically need a clinical setting, so they cannot be done at a home, which is why the importance of an objective, accessible, and standardized solution is growing. Now, for our research objective was to design and evaluate a proof of concept application that digitizes this test and can objectively assess tremor and measurable features rather than visual judgment. This is our system overview. Here you can see there are many use cases and everything is stored locally on the database. There is no cloud and the user can take tests and they can view their test results history so they can see if it's basically worsening over time and the performance. Now, this is the flow of how the system is. The system begins when the user starts this test and chases a spiral on the screen. As the user draws, the system will capture X and Y coordinates with the timestamps. These data points will then be processed to find meaningful features. We'll be talking about this soon. And then it will classify the test, and show the results. Now, for the data acquisition, this application can run on Android smartphones, Windows devices using an emulator, and the user input can be taken through various methods like the touch screen or using a mouse if you're on the desktop, or a stylus input if it's supported by the device. Now, for the sampling frequency, we're using 120 Hertz. This high sampling rate will allow us to have better precision and a more detailed motion analysis. Now, traditionally, kinematic features that could be used were velocity, acceleration, and curvature to detect any abnormalities. But in this application, we decided to go with the average deviation and the jerk. They are combined using a weighted score formula, and that is how we are seeing if the drawing deviates from the ideal curve. Now, the deviation is calculated by fitting the data points to an Archimedes spiral equation, and then it will be basically compared. And the jerk will represent the smoothness of the motion. So if there is any shaking, the jerk will be affected by it. Now, these two features are combined using the weighted score formula. This is the weighted score formula. It takes in the average jerk, the jerk maximum, and we currently have a threshold. So if it exceeds this threshold, it will be marked as Parkinson's. And this is a short video to show how the findings would be. So here you just enter your display name and you can start the test. This is basically how this is simulated, but this is how it would be for someone with Parkinson's disease. And this is how it would look like for someone that's basically not with Parkinson's. Yeah, it shows no significant PD symptoms. Now for the results. After using the geometric deviation and the weighted score formula, we established that it can reliably distinguish between healthy and tremor-like spiral drawings. Now for the healthy, we noticed a pattern that there was a lower geometric deviation score, there was a lower average score, and the spirals were usually smooth and continuous. There was no breaking in the drawing, and there was high repeatability across trials. So basically, all of the tests they would be very similar in terms of results. But now, if we talk about with stimulated tremor, we noticed that it had higher deviation scores. There was a higher average jerk, and there was irregular paths with the visible oscillations. So there would be out of shaking basically, and increased variability between trials. So it would differ a lot each test they would take. Now, this is a graph to help represent it. The blue line is basically a threshold, and this is the true positives and false negatives. You can see that there was a small amount of false negatives here and there, but overall it was reliable, and it was able to distinguish between healthy and unhealthy patterns. Now the problem with this is we did not test it on any Parkinson's disease patients. All of the spiral drawings were basically simulated. We had a small sample test size, and older users may face usability issues since it will be on the phone or a desktop. So they might face issues downloading it or using it. For our future work, we want to have clinical validation. We want to incorporate more tests, and we also want to add machine learning to help reduce the amount of false negatives. Now, for the conclusion, we want a feasible digital screening tool that can be used at home. It's quantifiable, so it will not change depending on the clinician. It's accessible and low cost, smartphone-based solution, so anyone can be able to use it. It will successfully differentiate between healthy and tremor-like drawings, and it has shown that there are promising early results. This is our references, and that is it. Do you have any questions?
Any question for Rami from the floor? It's very interesting, yeah, Mr. Rami, the application that you developed. It's just that yeah, I found it very interesting. Okay, the test, what we call that one? What test just now you are saying? The
Archimedes
drawing.
spiral.
Yeah, Parkinson's spike. Okay, but yeah, because you haven't run for no clinical testing has been conducted, right?
Yeah.
Because
Yes.
there are people that not have Parkinson, but they have a problem in you know, to do the spiral as well, right? So how you plan to ensure that the apps works exactly like it's supposed to work? I mean, to differentiate between people who had Parkinson and people who not having a Parkinson, but they do have, you know, some problem with the movement. How you think that you're gonna isolate that problem?
Yeah. After
Yes,
doing research
Professor.
on it,
Yeah, Rami. Thank you. Thank you, Rami. This is Hishi Lim and uh, Professor Amir. Thank you very much for that question. Indeed, we are aware that there could be muscle issue, there could be other tremor that is not necessarily leading to Parkinson's disease. And that's why in our future work, we are looking at some kind of machine learning to improve on that, and also agentic AI that we are going to add on. It is now very initial work, exploratory work, but definitely we are aware of that false negative that Rami has reported earlier. Rami, go ahead if you have some other things to add.
Okay.
No, that's it.
Okay. It's very interesting because now we can use the technology to help people, especially in medical. Okay, and we know that there are many, there have been AI in many application applied in hospital as well, right? To differentiate
Yeah.
or to classify cancerous, okay, and other more sickness. So I do hope that your research will bring this technology to benefit others in the future. And as what the professor said just now, it's important to differentiate between real Parkinson tremor as well as muscles. So that people can easily for doctor to make a decision whether it's a Parkinson or not, right? Okay, thank you so
Yeah.
much, Rami. It's very
Okay, thank you
interesting.
so much.
All
Thank
right.
you.
Okay, Alicia, back to you.
Thank you. The next presentation is by Gladstone Sunway, who will be presenting fine-tuning Times FM for operational mobile traffic forecasting. Gladstone, you may now begin.
Good afternoon, everyone. Can you hear me?
Yeah. Yes.
Okay. So I'll be sharing my screen. Can you see my screen?
Yes, yes. We can see your screen.
Okay. So good afternoon, everyone. I'm Gladstone Sanvier. I'm a PhD student affiliated with the Liston Laboratory of Université de Technologie de Troyes in France and the Lama Laboratory of Université de Lomé in Togo. So I'm pleased to present you our work titled Fine-Tuning Thames FM for Operational Mobile Traffic Forecasting. This work was part of my PhD and was supervised by my co-authors and was funded by the SCAC service of Ambassade de France au Togo. In recent years, you have seen the emergence of time series foundation model like Time FM from Google, Uomo, Chronos from Amazon, and Time GPT. So those models have been trained on large corpora of the time series data, and they have been trained to recognize and to detect general pattern in time series data. They have shown impressive zero-shot forecasting performances, and they have developed the capacity to be adapted to specific domain through fine-tuning with a relatively small amount of data. So the interest of this model is their capacity to adapt to relative to domains and to files where data are scarce. For example, in the Times FM paper, the authors have demonstrated that fine-tuning Times FM for electricity data can improve performances to a state-of-the-art level. But there are some gaps in telecoms. First, we have a very limited application in mobile networks. We can talk about Uomo, who is mobile network oriented, but it's difficult to consider it like a general purpose foundation time series model since it was only trained on telecom data. And third, the impact of fine tuning on telecom question or telecom file is remain poorly understood. So in this work, we want to answer this question. Does fine-tuning time series general purpose time series foundation model, does fine-tuning improve significantly its performances? So our interest is on the impact of fine-tuning on forecasting performances and the effectiveness for mobile network traffic prediction. To answer this question, we want to evaluate the performance of the base Thames FM model on telecom data. We want to fine-tune the model using parameter efficiency adaptation technique. We want to compare forecasting accuracy with state-of-the-art deep learning models, and we want to quantify the performance gain induced by fine-tuning. The data we used in our experimentation is from call detail record data from Milan. So this data set include data for internet, SMS, and call activity. But we specifically targeted the data or the internet activity surrounding the Giuseppe Meazza Stadium. And the reason we targeted this specific zone is because the traffic in this zone was influenced by large events such as football matches. On the graph, in this graph, you can see in the blue we have the internet traffic, and in the orange line we have the presence of events such as football matches. And we can see there is a high correlation between the high traffic on the internet network and the presence of football matches. So with this data, we have fine-tuned the Google Times FM model, to which we refer to as TFB, to obtain a new fine-tuned model, a new fine-tuned version, to which we refer as TFF. After that, we compare the performances of our base model and our fine-tuned model to deep learning state-of-the-art forecasting model like DeepAR, TCN, TFT, NBITS, and transformers. Here are some detail in the implementation. We start from the raw Milan CDI data, and we do some pre-processing, filtering and normalizing. And after this step of pre-processing, we proceed with the slicing into windows because we want to use a context. The models will have to use a context to predict into the future. So we will use a context of 512 data points. And using this context, the model will have to predict 128 points forward. So for the fine tuning, we use a LoRa technique with a rank of 8 and the alpha parameter of 16. For optimization algorithm, we use the ADAM-W with a learning rate to 1 time 10 power minus 5. We use a batch size of 32 during 20 epochs, but we also use early stopping with a patience of 5. The code of the implementation has been executed on a Google Colab environment with 15 gigabytes of virtual RAM. And we use PyTorch 2.2 and Hugging Face Transformer library for the fine tuning, and that for implementation of the other baseline models. Here are the results of our experimentation. We have used RMSE, the root mean squared error and the mean absolute error as metrics. And we can see that before fine-tuning, the foundational term series model has scored 0.921 like MAE and 1.146 like RMSE. But after fine-tuning, those error rates has dropped to 0.552 for the MAE and 0.753 for the RMSE. Here you can see a significant improvement over the base model of almost 40% reduction in MAE and 35% in RMSE. We can also notice that TCN is the best performing model, and the fine-tuned version of the foundation model is the second best performing models. Globally, we can see that the foundation model, the base one and the fine-tuned one, perform to approximately the same level at the other state-of-the-art deep learning models. Here on this graph, you can see in the plain dark line the ground truth of some a sample of data. And in the dashed black line, we have the prediction of the base model. And in the blue dashed line, we have the prediction of the fine-tuned models. Here we can see that the fine-tuned model appears to be better adapted to the local real data. So we conclude that fine-tuning enabled adaptation to local telecom activity pattern, enhence improving prediction accuracy. We have conducted some further experiences on sensitivity analysis on the rank parameters in the LoRa technique, and we arrived to the conclusion that globally the metric decrease, the metrics decrease as the rank of the LoRa increase. So the performance are better with a larger rank, but it comes with a higher cost in computation. After those experimentation, we can conclude that fine-tuning a time series foundation model with LoRa improve the performances to a state-of-the-art level in mobile network traffic forecasting. And that can be really interesting because we can use a small amount of data to adapt to telecom data when the data is scarce in some country, for example. For future work, we can extend the analysis to another foundation model like Chronos and TimeGPT, or perhaps a different telecom data sets. But what are also interesting, like we're investigating the incorporation of exogenous variable into the prediction. And we're also investigating the transfer of NLP-inspired technique to time series like in-context learning, for example. That can be really interesting. So thank you for attention. I'm at the end of the presentation, and I'll be happy to have any remarks or questions from you.
Thank you, Mr. Sanvi. Sorry if I pronounce it wrongly. Okay, do we have any question from the floor? Any question from the floor? Okay. This is you are fine-tuning time series model, right? Times FM?
Yeah, Times FM.
Time FM is a time series model, right?
It is a time series foundation model.
Time series foundation model. So how robust is your model to cater sudden traffic spike? Did you have you simulate over sudden traffic spike to do the forecasting, to look whether the model can actually forecast if there are any significant changes in the traffic?
Yes, we have choose explicitly the data of area where there is a sudden spike in the data to see how the model is performing, and that's actually one of the reasons we choose the San Siro Stadium area. And we have seen that the model is performing better than almost all of the TCN, almost of the deep learning models, except from the TCN, which seem to be better adapted to those kind of data.
Okay, so it does capture long-term and short-term temporal patterns, yeah, using this times FM. It do capture.
Yes.
Okay.
Yes.
All right. Okay. I think it's a good works to look into because we can predict many networks nowadays, right? Okay, we can predict this what we call this one. You are focusing on the mobile traffic forecasting whereby it can also go for any telco network switching between tower to tower, correct or not? To see which one that have more bandwidth, then you can switch to that.
Yeah, that can be interesting, I think also.
Oh.
But we have not investigated this part of the regression.
Okay.
We only work on mobile traffic forecasting.
Mobile traffic. Okay. But perhaps the model also can be used in another domain if it works in the mobile traffic. That's what I'm saying.
Yes. The interest of foundation model is is the fact that they have learned general patterns in time series. So they leverage this general knowledge so we can apply it in several domains. And that's what is interesting. But the thing is, in practice, when you are using it in a specialized domain, the performance is not quite good. So you'll have to fine tune it to with a small amount of data from that domain to make it work really well.
Yeah, because it does not generate enough to cater for every domain, right? Or not? So every domain have to fine tune to make the model work well. Yeah. Okay,
Yeah,
good.
it's like it. Okay.
No, you can say what you want to say, Mr. Sanvi.
Yeah, so I was saying that it was like it only has general knowledge. And if you want to talk to him from a specific sub-subject, you have to fine-tune it for that subject and to see if you have a good result or not.
Yeah, understood. Okay, thank you. Thank you so much. It's very good work.
Thank you.
All right. Okay, Alicia, yeah. Do we need
Yeah, our final paper for today is by Sakshi Dhumone, who will be presenting our second last paper for today is by Sakshi Dhumone, who will be presenting hybrid system for smart healthcare monitoring using AI and IoT. Sakshi, you may now begin.
Yes, ma'am. Thank you. My screen is visible, ma'am.
Yeah. Yes, but please make it presentation view. Okay, yeah, now good. You're good to go.
Okay. Thank you, ma'am. Good afternoon, everyone. I am Sakshi Dumane, and this is my co-author, Supriya Narad, ma'am. Today, I will present our research on hybrid smart healthcare monitoring using AI and IoT. This system helps monitor patient health continuously using smart device and artificial intelligence. This is the outline of our presentation. First, I will introduce to the topic. Then I will explain objective literature review and methodology. After that, I will show results, challenges, and future scope. Final, I will conclude the presentation. This is introduction. Health is considered one of the most valuable asset of human life. Health is one of the most important part of the human life. Today, many people suffering for disease like diabetes and health problems. These diseases need continuously monitoring, not just hospital visits. AI and IoT technologies helps monitor patient and in real times. Wearable device collect health data like health rate and temperatures. This data helps doctor detect problems early. IoT enable wearable device of physiological data such as heart, blood, oxygen level, and temperature. Second is objective. The main objective of this research is designed to implement a hybrid smart healthcare monitoring system, integrate artificial intelligence and Internet of Things technology. The main objective is to develop a smart healthcare monitoring system. This system combines artificial intelligence and IoT. It's monitor patient continuously. It also detect health problems automatically. The system sends alerts when abnormal condition occur. To ensure diagnosis and improve patient care. To support early diagnosis, chronic disease management, and timely medical information, thereby improving overall patient care and healthcare efficiency. Literature review. Previous research show that IoT device help in continuous health monitoring and real-time data collection. Many research IoT device helps in continuous monitoring. AI improve diagnosis or accuracy. And AI models such as CNN and LSTM improve disease prediction accuracy. Machine learning models field challenges like security and data accuracy. This is my literature review. Proposed methodology. Our system use a hybrid architecture with 4 layers. First is device layer, edge layer, cloud layer, and application layer. Device layer, wearable sensors collect patient data. Edge layer, process data quickly and reduce delay. Cloud layer, storage data and runs AI models. Application cloud layer, storage data and run AI models. Application layer, show data and alerts to doctor and patient. This architecture improves speed, accuracy, and efficiency. First is give a gateway, smartphones, edge computing, cloud analytics, and application layer, doctor's dashboard, and patient mobile app. Implementation methodology. The system works in several steps. First, wearable sensor collect data such as heart rate, oxygen level, and temperature. Second, the data is sent to gateway device like smartphones using Bluetooth or Wi-Fi. Third is edge computing, processes data, and moves noise. Fourth is cloud computing. Cloud computing store data and AI models analyze it. Fifth is it is any abnormal condition is detect, the system send alert to doctor or patient. It is alerting and visualization. The result and discussion. The results show that the pro- proposed system successfully collect the analyzed patient health data such as IoT sensors, edge computing, cloud infrastructure, and AI algorithm to support continuously health monitoring. Physiological data such as heart rate, body temperature we successfully collect using wearable IoT device. AI improve accuracy in detect health problems. The system can send alert early which helps in timely medical treatment. AI-based analytics run on the cloud showing high effectiveness in detecting abnormal patterns and predicting high heart risks. Discussion. Hybrid edge cloud approach balance speed and scalability. AI model enhance early disease for the improving patient data and health problems to provide the system can be sent uh, data and we can reduce workload on hospitals and clinic lives. Challenges and limitations. Some challenges still exist, such as data privacy and privacy security risks, integration of the integration of different devices and systems, i- integrated data for multiple sensors, platforms, and healthcare system can be complex. Although standards such as HFIR are used, variation in data for format and device compatibility may still affect seamless integration issues due to sensors error. These challenges need to further improvement in this research. This can be impact the reliability of AI-based prediction. One of the most important direction in this research integration of advanced deep learning model such as transformers based architectures to improve prediction accuracy and support more complex disease diagnosis. This is accurate to change the challenges for patient security, data security, and manage the data for the record and manage the uh, patient record, biometric blood pressure, glucose monitoring, and ECG sensors to enable comprehensive multiple parameters health monitor. Conclusion. In this conclusion, this research show that combining AI and IoT can create an effective healthcare monitoring system. It enables continuously monitoring, early disease detection, and fast medical response. This system can improve patient care and reduce hospital workload. Hybrid AI and Internet of Things system have great potential in the future of the healthcare. Reference in my research paper. Thank you for your time and attention. I will be happy to answer any questions.
Okay, we have question from Dr. Lee, right?
Yes, thank you. Thank you for a great presentation. And I just have a question, whether you encounter where different hospital, whether it's public or private, does it allow the easy sharing of the data that you're talking about? Because over here in our place in Dubai, where private hospitals are concerned, they are quite sticky about sharing data and information. I don't know if you have the same issue in India on your side. I'm not sure about in Malaysia. Maybe Malaysia also have issues about sharing data across basically not security of data, but governance of data, and also public hospital. One hospital is not too willing to share the data because it represents revenue.
Yeah.
You care to comment on that? Thank you.
Okay, Sashi, can you comment on that?
Yes.
Sashi,
Yes, ma'am.
did you did you hear the question just now from Dr. Lim? It's
Yes,
about
ma'am.
sharing of data from the hospital.
Yes.
Okay.
Sakshi, we're unable to hear you. Could you please speak up?
Yes, ma'am.
Okay, there's a question from Dr. Lim just now, right? About the data governance just now.
Yes, yes.
Sharing of data from the hospital. So what will be your comment on that?
Yes. In India, we facing similar challenges regarding data sharing between hospitals, especially private hospitals. Many hospitals are recalculated to share patient data not only because it privacy and security concerns, but also because the data, governments, policy, and institutional complaints.
So how you manage to get your data for your research? Is there the one just now you are saying that you run the data, right, from the hospital itself, correct or not? I'm sorry if I'm wrong.
No.
So how you get your data for your pilot study for your model? I mean for your system?
Yes. For this research, we did not use confident hospital data.
Okay.
We use simultaneously and publicly available data set. In the futures, real hospital data would not use this research paper.
Okay. Right. Have you approached the hospital for any test bed study for your research?
Yes.
And it's a privacy issue, right? It's privacy and confidentiality data, correct or not?
Yes.
Okay. Yeah. I think in Malaysia also we do have governance issue with regards to sharing patient data between hospital to hospital and even between the hospital and the researcher. Okay.
Yes.
But we do hope that we can have some collaboration between hospital and researchers so that we can use, real data for the benefit of the hospital as well, correct or not? Just like just like our researcher just now, Rami is doing on Parkinson, and he yet to test on the hospital. So I myself hoping that we can check some of the hospital data, but of course lah in the most appropriate way, because that involve many private data inside that. But I don't know, Dr. Lim, how would be your clinical test on your application letter with Rami?
Yeah, thank you, Professor. Well, actually, this is also our concern. So, moving forward, we want to address a two-part. One is to make sure that we get like-minded researchers and agencies who can allow us to work, and also maybe establish some formal MOU, and especially with hospitals. Uh, and we have a couple of those hospitals that have a little bit easier data governance policy, like some private hospital, they may be able to be more relaxed in certain area, or establish some pilot project that allow us to do exploratory work without infringing into any of the patient data and stuff like that. So yeah, we are exploring this, but this is definitely an issue that a concern that we see. Thank you, Professor.
Yeah, it's true. Okay, thank you, Dr. Lim. Okay, Alicia, I think we go to our final presenter, right? Mr. Silvio Simani.
Yes, ma'am. So, yeah, our final presenter for today is Silvio Simani, who will be presenting his paper on residual-based interpretable learning for fault detection in floating offshore wind turbines. You may now begin.
Thank you. Thank you for your kind introduction. I'm going to share. Okay. So thank you. This is a joint work between myself as a supervisor of a couple of students visiting my department, and Dr. now is working at the Dyson Institute of Technology, and a visiting student from China who was supposed to give this presentation, but due to the different time zone was quite difficult for him and his supervisor, Professor Manchu. So the target is a little bit different from the previous presentations because our framework is focused on floating wind turbines. So, because especially the topic is considering this power system for producing energy, and why we are now considering floating, because this simplifies the installation, and on the other hand, it improves also the energy generation, because of course you can consider these installations to be placed in the middle of the sea. Of course, this solution provides some other problems, because it means that these devices are completely lost in the sea, and in the case of malfunctions or faults, as is common refer to any malfunction, is really difficult to reach these devices, especially due to the harsh remote marine environment, and in case of harsh environment. So it's why to propose some, let's say, solutions in order to possibly plan any, for example, plan of operation and maintenance activity, which is intended to reduce the final cost of the energy. So it's why we are, at least in the framework, we considered let's say, the topic which was focused on machine learning approaches. One of the problem of this machine learning solution is that normally you lose the let's say the interpretation, because you are working with data, and you miss the maybe the meaning of the reality. So it's why we are trying to providing an interpretable machine learning system, which is obtained, at least in this work, by combining support vector machines, which are used for mainly detecting or extracting the features from the data, and a decision tree. A decision tree is another tool which is integrated into this support vector machine methodology in order to help the possibly technician maybe cannot be, for example, familiar with the data, and to find the occurrence of the fault. So we are exploiting. Of course, it's very difficult. In some cases, it's quite difficult to work with real data. So we took the opportunity of working with a recently developed benchmark, which is represented by this floating wind turbine simulator, which was provided the last year for especially for a conference. SISTOL conference is a periodic event which is run every 2 years, and this let's say simulator is able to replicate with a very high accuracy the working conditions of a floating wind turbine system. It contains, I don't want to enter into the details, but in practice, it contains a number of single wind turbines which were already proposed as a benchmark in 2009 for another competition. And now the results, let's say, of this, because this work was transformed also in, I forgot to mention, as a competition, which was run the last year and then was reproposed for the World Congress in our community, the IFAC World Congress, International Federation of Automatic Control, which will be organized in Korea in August this year. So the challenging is because the challenge points are represented by the uncertainty occurring in a system due to the different environment, turbulence of the sea, of the weather, of the waves of the sea. So this benchmark is able to simulate all these conditions. This is a very simple description of the system of this benchmark. Of course, there is also a public part of this benchmark, which is freely available from the web with the data. It was developed in a MATLAB and Simulink environment, or for those of you who are working with this software. It contains different realistic folds. I mentioned it here, the most important in this preliminary part of the work. We consider it just sensor faults because they are quite easy to detect. For the, let's say, the follow-up of this work, we considered also the actuators. It means the pitch actuator of the floating wind turbine and also the generator torque. So it represents a further work which is still going on this system. So we considered several aspects. So we need to extract the features. So features means the characteristic, let's say, aspects of the data, and what we called an ensemble strategy, because it combines two techniques, machine learning techniques, in specifically decision tree and support vector machine. Why we are considering this joint methodology? Because we want to derive and obtain an interpretable methodology in order to help also the understanding, not only to provide a solution as a black box approach, but also to check it if it's really the answer is really correct. The starting point is the generation of the data. As I already mentioned, we are considering the generator signal. So quite simply, we are generating the residuals. The residuals are normally diagnostic signals, which are the characteristic that they are around zero without fault, and they are different from zero in case of fault. Of course, due to the noise, because the task would be really easy if we don't have any noise or we perfectly know the model. The most challenging points are derived from the presence of the noise, inaccuracies, which makes this, let's say, residual almost different from zero. So you cannot distinguish simply. So it's why you need something in order to extract the features which are sensitive to faults and then to use this technique. we are using basic features that normally are applies to audio signals. For example, the residual mean shift. So it means they are not specific to this kind of application, but they applies to a more general framework. For example, the residual mean shift, the variance, stability measure, autocorrelation, a spectral entropy. So there are some crucial features. Of course, they are not always appropriate, because in the case of very strong nonlinearities, these features are quite useless. But in this case, they are working quite well, because in fact, if you see here from a picture of this, of course, not of the residual, but of the final results, you can see that from this feature, you can understand that there is a possible separation of the data. So in principle, it shows that the feasibility study can be successful. So
excuse me.
Yeah.
I'm sorry to interrupt, but you have 2 minutes left.
Sorry?
You have 2 minutes left right now.
Okay. Yeah. So in principle, we try to include these two techniques in a overall framework. And so the final decision task was really simple, because you have a final answer of 1 if there is a fault, or 0 if there is no fault. So the decision is very clear. I'm just skipping these details, so you can find everything in the paper. So you need to split the data, you perform a cross-validation. Of course, you need an optimization of your results, and we compare a traditional geometric threshold, which is very sensitive, as you can see here, to the noise, and the potential, the superiority of the methodology that we are proposing in terms of normally detection rate and false alarm rate. So in this, as a summary, in this approach, we were able to obtain the highest fault detection rate, which means that this approach can be interesting for real applications. And also we perform a preliminary analysis of the robustness, which is, for example, here, it demonstrates that our methodology is superior with let's say, a traditional application. So further works are mainly oriented to the generalization of this methodology, and especially as in any application, to apply this approach to real data, and also considering the isolation, because it's still open, this problem of the isolation. I mean, the isolation is intended to find where the fault is originated, and also a broader set of faults. In summary, this is the methodology. The superiority was demonstrated, at least in this first approach, and it provides a practical tool for diagnosis faults. Thank you for your attention. This concludes my presentation.
Thank you, Mr. Silvio Simani. It's very interesting story. It's regards to energy that we harvest from the offshore wind turbine, right? And from the study, the data is taken from the simulation, right? So there's no real data taken from the offshore yet up to now. We don't have the data set. So is that the way forward after this? You guys planning to have to collect the data from the actual turbine?
Actually, yes, we are planning through mainly through international projects. Is something that we are aiming to. Yes.
This is very is needed because using machine learning we can do so many prediction, right? And it's good to know that when the turbine is having need to be services or whatsoever, so we don't want to wait until the things become, cannot be used, then only we start to think on how to repair and whatsoever, and it will cost so many, it will cost a lot with regards to that. I think with regards to our in Malaysia, we don't have the offshore wind turbines, but we do have those electricity that runs through the what we call this one, dam, and also run through the coil, right? So we also need to ensure that the equipment can be, if any faulty can be detected earlier. So that's the use of the technology. And we should actually, utilize this technology for the benefit of human mind. Okay, thank you so much.
Thank
It's
you.
very interesting.
You're welcome. Thank you.
Okay.
Thank you to everybody.
All right. So, Alicia, I would like to do my concluding remarks for all the presenter. Yeah.
Okay, of course.
So to all presenter, thank you so much for your wonderful papers and the knowledge that you shared today. There's so many things that I myself learned from the, from the machine learning perspective, from this energy, from the medical things, and from the mobile traffic forecasting. It's very interesting, and I do hope that all this research will become something that is tangible and bring benefit to the humankind. Okay. With that, thank you so much to the conference organizer also for inviting me to become a session chair. And thank you, everyone. Okay, back to you,
Thank you, Professor. Thank you for the great presentation. Thank you for great
Thank you.
effort, everyone.
Thank you.
Thank you,
everyone.
Thank you to the organizer.
Thank you.
I would like to deliver the closing remarks now as well. So I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative for everyone, and on the behalf of the whole team, I would like to thank everyone for supporting us during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICICT 2026. I also thank our session chair, Dr. Asmidar Abu Bakar, for chairing this session. And on behalf of the team ICICT 2026 and Global Knowledge Research Foundation and partners, I would like to present the Certificate of Appreciation to you. Thank you for your valuable presence.
May I take the picture now? Thank you, Alicia, and the conference team. It's my pleasure to be with all of you and to listen to all the good research conducted. Okay, thank you so much.
Thank you. Just before we conclude, I would request everyone to please turn on your cameras for a quick virtual snapshot. Thank you, everyone. Stay safe and take care. The session is now adjourned.
Thank you so much, everyone.
Thank you so
Thank
much.
you again.
Thank you.
Thank you.
Bye.
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 Thank you. Bye.